This is my worst problem number 5 for the Thermo Charette number 2. Now consider an 18-meter diameter hot air balloon that, together with its cage, has a mass of 120 kilograms when empty. The air in the balloon, which is now carrying 285 kilogram people, is heated by propane burners at a location where the atmospheric pressure and temperature are 93 kilopascals and 12 degrees Celsius respectively. Determine the average temperature of the air in the balloon when the balloon first starts rising. Now, we're going to use a couple equations to solve this, and we're going to need a couple of constants. First, we're going to solve for the volume of the balloon, V. Now, we also know that, before we do anything, we know that air is an ideal gas, so we can use the ideal gas law in solving this equation. Now first we're going to get the volume of the hot air balloon. We know that the volume is going to equal 4 pi r cubed over 3. And we know that it gave us an 18-meter diameter, so the radius is going to be 9 meters. So it's 4 pi of 9 cubed over 3. That comes out to be 3,054 cubic meters of air. It's a hot air balloon, so that makes sense. It's going to be pretty big. Now, we're going to then move on and calculate the density of the cool air. And we're going to calculate these different variables, and I'm going to put them together in an equation. And we're going to calculate the density of the cool air next. Now, we know from our tables that R is going to equal 0.287 kilopascals times cubic meters kilograms Kelvin. And we know T is going to equal 12 degrees Celsius, and P equals 93 kPa. Now, plugging these all in, we get 93 over 0.287 times 12 plus 273, because we want it in Kelvin for the ideal gas law. So our cool air density is going to equal 1.137 kilograms per cubic meters. Now that we have our density and our volume, we can calculate our buoyancy force. And our buoyancy force is going to be this equation right here. The buoyancy force is equal to the density times the volume times the gravity G. Now, you know that our buoyancy force is going to equal our density, which is 1.137, times our gravitational constant, which is 9.8 meters per second squared, times our volume V, which is 3,054 cubic meters. Calculate that together. It's going to be 34,029 newtons for our buoyancy force. Now that we have our buoyancy force, we can calculate we can figure out what the